screen, you should see 13a, e to the x
Yep.
equals 5. You undo e with ln. Okay, so it's the natural log of e to the x equals natural log of 5. You're undoing e with ln, so on the left side it just becomes x. The right side is the natural log of 5. Hopefully you've seen that before. Nothing there looks,
Yep.
odd. So b is like the other way. The kind of the opposite direction, or one's forwards, one's backwards. The way you undo natural log is with e. So you write it's like saying I'm going to do the e to both sides of the equation. It's not really the right language, but they undo each other. So the left side just becomes x, the right side is e squared. So see how there's an e in both places.
Uh-huh.
And this is review. You've seen this in prerequisite classes. See how there's an ln in both places.
Yeah.
That's your prerequisite stuff there. Okay. 14. Do you want to do that one?
Yep.
Okay. 14. As always, if you want some like this, just let me know, and I can make those real quick for you. So this one is like annoying because it's got an e to the x. If u was e to the x, this would be e to the u equals 2. Like, you have to treat this thing as if it's like a variable, or just it's there. So how do you undo e? Well, it's the same as part A. You take the natural log of both sides. So here, natural log undoes e, so it becomes u equals natural log of 2. But you're not solving for u. U is really e to the x. So you put that back in, and it's like, well, how do you undo e again? Well, it's the same deal. You take the natural log of both sides, and you can take the natural log of the natural log. It's just an operator. Like, you just do it and then you do it again. So maybe it looks funny, but it is totally okay. So the right side is the natural log of the natural log of 2.
All righty.
Okay. Okay. B is quite odd to me because it's like in this section where maybe they're using like a definition of arctangent that I'm not quite sure of. Did you talk about arctangent in terms of logs or e's or anything like that?
He just gave us the formula for it, like to
Can you?
find a derivative of it,
Well, this isn't a derivative. This is just like
solving just for it.
yeah. See, it just doesn't fit here. On the unit circle at pi over 4, the tangent of pi over 4 equals root 2 over 2 over root 2 over 2, which equals 1. So like the answer here is x equals pi over 4.
Uh-huh.
But like, I don't know how to explain that other than to say like this is a unit circle problem. It's not
Yeah.
an e or a log problem unless there's something I've never seen before. How you express e tangent inverse in terms of e and ln. So you may I guess I'm saying you may have to go to your instructor on that one to find out what did you mean. What did you mean by that? Okay, so we'll go to 15a. 15a is based on knowing the property of how to, they call it condensing. So if you have the natural log of a plus the natural log of b, like you have here, what ends up happening is this becomes the natural log of a times b. And we're looking at everything I just showed you for this part here, b. So basically, you get to multiply what's inside parentheses. So the natural log, your a in this case is x plus 1, your b is x minus 1. It's x plus 1 times x minus 1 equals 1. Is that okay so far?
Yep.
Okay. Now, you could choose to multiply what's inside. This is difference of squares. So it simplifies to x squared minus 1. If you FOIL it, you will see that, but it is difference of squares. And from an earlier problem we did, how do you undo ln? You undo ln with e. e to the natural log of x squared minus 1 equals e to the 1. You get just the thing that's inside the inside there. I actually don't need the parentheses on this. And e to the 1 is e to the 1. So now you can still solve for x. It just kind of maybe feels uncomfortable. You add 1 to both sides, so it's e plus 1 because you add 1. Then you take the square root of both sides, so x equals plus or minus the square root of e plus 1. So there's 2 solutions, but we have to check them. You have to check for extraneous.
Uh-huh.
And usually it's the negative one, but not because it's negative. It's because when you put it back in here, that it becomes a negative number.
Oh, okay.
So, if you're looking for kind of the 80% thing that works 80% of the time, choose the positive. But having said all that, if you have an instructor that likes to go against the grain, that might not work.
Alrighty.
Okay, part B. Part B. Okay, so log base 5, c to the x. So the property we want to use here is log base b of x to the n equals n log base b of x. Basically, you can bring that exponent out in front. So this x is the exponent, and you're going to bring that out in front. So the reduction step here is this becomes x times log base 5 of c equals d. So normally it's a number, like normally it's like log base b of x to the 5, you bring the 5 out in front, or 4 or whatever. We're solving for x, so we're going to divide both sides by log base 5 of c, log base 5 of c. So on the right here is your final answer. I may need to show you an alternative way of doing this that sort of undoes the no, I think this is the only way you can do this. So this is it here.
All right.
So is there anything there that you would like me to review again or go over?
No, I'm just gonna need practice.
Yeah.
That's really it. I just gotta get, we went over this so long ago. I
Yeah.
just need a reminder of how to do it.
All right. So you send another picture over. Differentiate. 17 through 43. Is that on the
Me. It says to do 17 through 26.
okay. All of them or just the odds?
It says all of them.
Okay. All right. So let me snip in. I'm going to suggest we do the evens and come back and do the odds. If we have time, is that
Yeah,
okay? Or
that's good.
it's up, you're up to you, the customer.
That's good with me.
Great. Okay. So this is what do you see here? Because that's really what matters. What's the like overarching rule that you might see here? What would you do first?
What's it called? My mind just, I know what it is, but I just can't think of the word.
All right, so
Product rule.
this is product
Yeah,
rule.
there
Okay,
you
and
go.
you got to see that right away. Because if you don't know where to start, it's impossible to do. M and N are numbers, so like they're constants, but you can think of it as like 3x or 5x, if that helps. But you should get comfortable with the idea that when you use the chain rule, you just multiply by m. So we keep the first function, e to the mx. Derivative of cosine is minus sine. Keep the inside function. The derivative of nx is n. That's the first part, plus. Okay. Keep the second, cosine nx. Derivative of e to the mx is itself times the derivative of the inside function, which is m. I'm sure I always ask, I don't remember if we need to simplify or not. I would only do
No,
that
that's
if
good. He doesn't say anything about simplifying still.
okay.
So.
Okay. Good enough here. All right, number 20. Okay. So like for me, I don't know how your instructor is. I think of this as like functions, power rule, um, quotient, and product. These are not in any particular order, but like these are like you have to pick one of these to start with. And for me, this is a function that you're starting with because ln is like the outermost thing.
Uh-huh.
Okay.
We use chain rule then.
Then use chain rule. So like all of these either lead to themselves or chain rule. Like power rule leads to chain rule, quotient, product rule leads to chain
Uh-huh.
rule. But like you could do a, power rule of a function that leads to chain rule. I mean, so in yes, you got it here. So the derivative is 1 over secant of x. Okay. And then what's the derivative of secant? So hopefully you're getting some, study time on that.
Mhm.
And that's how fast you got to be really like to do well in this class. Um, you got to know it. Now I know you don't want to. I know we talked about. Well, you don't need to simplify, but like it's kind of bad to not cancel out things like this. So the derivative is tangent because the two secants cancel,
Oh, okay.
and like that's the kind of thing where you probably had at least it's like making your bed every day. You might as well make your bed.
Alrighty.
Um, all right. So this is product rule right there. Boom. Now, if you don't know the derivative cosine inverse, that's fine. You definitely want to get to where you like, know it.
Mhm.
So, do you have that derivative table available to you? Do you have something that you're using to kind of?
It's in my notes somewhere.
Okay. Just again, just have one that you always use, look at,
Yep.
and do that. So I'm going to snip in the rule here for cosine inverse. It's like sine inverse, just the
It
negative
is
of it.
-1 on top.
Yeah, so it's totally doable once you only have to learn sine and then cosine's the negative of it. You already know that. So y prime here is x times -1 over square root 1 minus x squared. And just for clarity here, if this were like 2x, cosine inverse 2x, you would put 2x in parentheses squared. And then you'd
Oh,
multiply by
okay.
the chain rule. But so x really literally means whatever's in this x down here in the derivative is whatever you're taking the cosine inverse of.
Oh, okay.
Plus keep the first or keep the cosine inverse of x times derivative of x, which is 1.
Alrighty.
I was working with a student recently in calculus, and their instructor gave them like several of these inverse, cosine, sine, all this stuff, and you're like, really? Like, but that's depends on your instructor. You could
Yeah.
you don't know. So 24 we'll do next. We're definitely gonna be able to go back and do the odd ones as well. But okay, what do you see here? What's the overarching rule?
Quotient rule.
Quotient rule. So that is bottom. Bottom is 1 plus e to the t. Okay, times the derivative of the top, which is itself, minus the top times the derivative of the bottom, which again is itself, over the bottom squared.
Easy enough.
Yeah. And that's the speed you really want to be able to get to, if just to know like where your target is. You want to be able to say it and then do it. All right, so 26 is one of these like I call it like a non-obvious problem. You would have no way to do this problem if it didn't tell you that you need to use logarithmic differentiation. And that's another one on the list that I forgot to put up there, because you have a function to a function. Hopefully you saw some examples like that in class. So the first step here, it's a non-calculus step. You take the natural log of both sides of the equation. And on the left side, on the right side, this x comes out in front because of that rule we talked about earlier where the exponent comes out. So natural log y equals x times natural log cosine x. Okay. Now on the left side, you take the derivative implicitly. So like you treat y like it's an x. So the derivative is 1 over y. But then because it's a y, you always have 1 of y prime. Did you see that in class or if?
Yes, sir.
Okay, so that's clear. On the right, it's almost always product rule. A few exceptions, but almost always product rule. So it's just like we've been doing. It's x times the derivative of natural log is 1 over cosine x. Derivative of cosine is minus sine x plus natural log of cosine x. Derivative of x is 1. So I'm going to just slightly clean up everything here. Sine over cosine is tangent. So this becomes negative x tangent x plus natural log cosine x. We are not done though, because you have not solved for y prime. You still have y prime over y. So to make this work, you have to multiply both sides by y. And this is something you've seen in class. So sorry, it keeps, come on, don't do that. So your answer here ends up being everything on the right times y, and y is always your original function. So you go back to whatever you started with, and instead of y, it's the what was it? It was cosine x to the power of x. All of this is that original, and they always look like that. It's always times whatever the original is. So there's no exceptions to that.
Alrighty. All
right. So we're going to go through 17 because you need to get up through, you said 17 and 26, I think. So we're going to be able to definitely do all of these. Are there any that you want to try before, I jump in here and show you for this? Like, are any of these you're like, oh, I can do that for sure? Out of 17, 19, 21, 23, 25.
Or can you do 19 and 21?
Of course, I'll do them all. I just was
thinking. I was looking and those just caught my eye.
Okay. So let's look at 19 first. What is the overarching one here? Rule, derivative rule, quotient rule. Okay, so but within quotient rule, you have chain rule, because like x derivative of x squared is 2x, but e to the 1 over x is itself, and then the derivative of 1 over x. So keep that in mind. So we got y prime equals the bottom times the derivative of the top. So the derivative of e is itself. Okay, and if you need to, come off to the side. Oh yeah, what is the derivative of 1 over x? Because that's it's really x to the minus 1. So it's minus 1 x to the minus 2. So it ends up being negative 1 over x squared. This is right. So you may need to do it in the corner, but you should be able, okay, it's minus 1 over x squared. I got that. Minus the top times the derivative of the bottom. So the derivative of the bottom is 2x over the bottom squared. So even though it's already squared, you square it again.
Okay.
Do you feel good about your quotient rule formula? Like, do you feel like you could wake up in the morning and like, it?
Yes.
Okay, that's key here. All right, so let's do 21 next. Okay, so we did this a lot early on. I think we were working together. As I told you, sometimes there's a rewrite step, and it's not a calculus step. It's just like making this and putting this into a different form. So this is arctangent tan inverse to the 1/2 power. The square root is the 1/2 power. So that's your rewrite step. Right. So this is a power rule, because that's the outermost thing, followed by a function, like a thing that you just go look at your table and be like, oh yeah, it's there. So your derivative is start with power rule, bring the exponent down, keep the inside function, and you subtract 1 from the exponent. But the chain rule says, all right, you got to look at what's inside. What's inside is derivative of tan inverse. And again, that's one of those you just gotta like know.
Uh,
So one strategy, like you probably have heard these things before, but like one strategy is to write these all down real quick at the top of your exam if you don't know them.
yep.
Flashcards, like you just whatever you need to do. Like you gotta know.
So basically, the derivative of arctan is just like sine, but minus x, or wait, sine is
Let me
1 over square root of 1 minus x squared, right?
let me snip them in here in a way that maybe they will help help your learning, your understanding. So you need to know sine inverse really well. And then the only difference between sine and cosine is the negative out in front,
And then tangent, you just take away the square root, and then
but it's plus.
yeah.
So like my
See that?
preference, if we were learning this, if I were the instructor in front of you, I would have you learn you always want to create like a chain. Like if you know tan, there's a tan to cotangent.
Mhm.
There's a chain from sine to cosine. Like I don't feel like there's a chain from sine and cosine to tan inverse. That's easy. So like I'm asking you to know sine inverse, tan inverse, and secant inverse, and then use a chain to find
Right.
the related one: cosine inverse, cotangent inverse, cosecant inverse. So you only got to remember 3 plus the 3 chains. That's my suggestion. But you're right. I mean, it's without the square root, ends with the plus.
Mhm.
If you can do that, great. I mean, that's key here. Um, okay, so let's get back to what you sent me. I want to do 20. I want you to do 23 for me if you don't mind. I
All
think you
right.
can do it. We have plenty of time here. Um, this is one that you should be very comfortable with at this point.
Okay.
So give yourself a minute. Let me know when you're done, and I'll start working it out.
All right. All right. I'm done.
Okay, so the derivative here is t squared times 1 over t plus natural log of t times 2t. And it's worth simplifying, like whenever you have something over something like that.
Mhm.
So this would be kind of the like official answer. Is that okay?
Yep. That's what I got.
Cool. Let's have you do 17, and then I'll talk about 25 with you. I know you can do 17 here. So again, give yourself about a minute, and How are you doing on this one?
I'm still working. I was trying to identify what rule I wanted to use.
You should see it's a function followed by product,
Yep.
and maybe in quotes chain rule there. Take another 30 seconds. I'm just going to step away real quick. I'll be right back.
All right.
So hopefully you got at least to here where you
Yep.
take do 1 over, and then the next part is the derivative of the inside function there. So like if you didn't have the ln on the outside, it would be x times natural log of x, which is product rule.
Hmm.
So x times 1 over x plus natural log of x times 1.
Yep.
Okay. 25 is similar.
Hmm.
Like when I look at this, I see, okay, 3 to the x times natural log of x. So my outer thing is a function, and function always leads to chain rule. And the chain rule this time means like, well, what's inside parentheses here? What's the next innermost function? The chain rule is product rule this time.
Uh-huh.
Like there is no chain rule. Like it's a blanket word for like all these things that are elements are representative of the chain rule.
All right.
Sometimes it's the power rule. So your derivative here is itself x natural log of x. You have to multiply by the natural log of 3 always, like whatever the base is.
Uh-huh.
But then you multiply by the derivative of x times natural log of x, the product rule there. And that's the same as before. It's x times 1 over x plus natural log of x times 1.
All right. I was thinking I got confused over when you would use like when you set both sides to natural log, but that's when
Okay.
you're solving for x and not taking derivative.
Well, but like if this, I mean, this is the classic exam question is y equals x to the x. You have
Uh-huh.
to find the derivative of this. So whenever you have a function to a function, and like x and x are functions, so it's a little bit weird
Uh-huh.
because you don't have a rule. Like you have a rule for a number to an x or x to a number, but you don't, but not x to x, or not cosine x to sine x, or anything like that.
Uh-huh.
So that's what's going on here. So that's where you take the natural log of both sides, and this is not a calculus step. It's just a like pre-calculus step, we'll say. And on the right, that whatever the exponent function is, it comes out front.
Okay.
Okay, so now on the left, it's a derivative implicitly. So you treat y like it's an x, it's 1 over y times the derivative of y, which is y prime. On the right, it's almost always product rule. We've done this one a bunch. It's x times 1 over x plus natural log of x times 1.
All right.
So then on the left side, it becomes y prime over y equals 1 plus natural log of x. You're solving for y prime, so you have to get y prime by itself. It is always the case that you get the original function y over there on the right, and instead of y, you write the original function. The original function was x to the x. So if you kind of got that down, let me give you one like it.
All right.
So let's say y equals x to the sine x. It's the same problem, same steps, natural log of both sides, y prime over y on the left, product rule on the right. Give this one a shot, okay?
Okay. All righty.
Do you think you got it?
Yep.
All right, so this, I'm going to skip a few steps here, but it becomes sine x natural log of x over here on the right. The left side, when you take the derivative, is y prime over y. And on the right, it's sine x times 1 over x plus natural log of x times cosine x. Okay, is that okay?
Yep.
And then again, that y comes over. So your y prime equals sine x over x plus natural log of x times cosine x, all in parentheses. And then y is on the outside, but the original function was x to the sine x, and that's your final answer there. So we got a couple minutes left here. Like it might be good to look at some more problems, just talk through them, or we have time to do maybe 1 or 2 more examples. You tell me where you'd like to go with that.
So could you go over again when to like set both sides to natural log or set both sides to E?
So you will never use E when you're doing a derivative. Only be ln.
Uh-huh.
So like all the stuff
Okay.
we did like earlier, let me just scroll up to it. Like it's rare. It's rare for you to get anything on your exam like this. I mean, I've seen it, but because like they're not testing you on this. This is like you need to be able to, do the push up to do the bench press or something. You got to like you need to know this to do the stuff we're doing down below, but like you're not gonna get tested on this.
Uh-huh.
So I'm not sure how helpful like that is, but let me try to explain with some examples here. So if y equals x squared, the derivative is 2x. This is x to a number, x to a number. Okay. If y equals 2 to the x, it's a number to x, and the derivative is itself times the natural log of the base.
Uh-huh.
So the only other possible variation on this is x to the x.
All right.
Okay, so like x to a number, that's power rule. Number to x, but now it's like x to the x. So here's some that you might see. You might see like x to the sine x, or x to the cosine x, or x to the ln x. Really anything, or it could be reversed. So it could be like natural log of x to the cosine x. Could be cosine x to the sine x. It's when you have like two of the ones that are on your sheet that I think I've sent you before here,
Uh-huh.
where one of them's in the exponent. So basically, if any of these are in the exponent, let me snip these in. That's really what when you're looking, you're like, oh, okay, we got a problem here. But it really needs to be in both. It needs to be both in the base and the exponent.
Okay.
You know, anytime you see any of these things in here in both positions,
Mm-hmm.
you're gonna do logarithmic differentiation.
Okay.
All right. Any other short questions? Follow up to that?
No, I'm gonna schedule an appointment tomorrow though, as well.
Okay.
And
Sounds good.
probably Thursday.
Sounds good. Look forward to helping you then. I'll send you the
Uh,
notes out right away here, and
Very
I'll
cool.
see you next time.
All right, see you.
Bye.